Hello everyone, in this video we'll be discussing about scale in and scale out operation. So what is scale in and scale out? It is basically adding or removing servers behind the load balancer on the basis of number of hits being received by it. So what is load balancer? Load balancer is a device that distributes traffic across number of servers. Here are the key requirements and prerequisites that must be fulfilled for the implementation of this use case. The first one is vRO Operations Manager. This is used to monitor the load balancer continuously along with forwarding the triggered alert to appropriate tool to perform scale in or scale out operation. The next one is vROPs server. This is a small Python application server that listens for requests from vRO Operations Manager and translates those requests into something that the intended endpoint can understand. The next one is vRO Orchestrator. This is used to run the appropriate workflow for scale in or scale out operation. The last one is NSX Load Balancer. This provides high availability service and distributes the network traffic load among multiple servers. Now let's see the process flow that is being used to implement this use case. The concept is to continuously monitor the number of HTTP requests and sessions on the load balancer using vRO Operations Manager. Here, we are more concerned about number of HTTP requests and number of current session on the load balancer. As the number of hits and session breaches the set threshold, the alert will be triggered in vRO Operations Manager. vROPs accepts the alert and sends it to vRO Orchestrator in the format accepted by it. Now, vRO Orchestrator will trigger a workflow which performs the action as per the triggered alert. And after the successful execution of this workflow, a machine will be added or deleted depending upon the scaling. Now, we are familiar about the concept, so let's see how we have implemented this use case in our lab. So this is a vRO Operations Manager. In this, we have created an alert for scale in and scale out operations. Now let me show you the alerts that we have created. This is a scaling alert. This alert will be triggered when the rate of HTTP request on the load balancer will be less than the set threshold. In this case, the workflow will remove the machine from the load balancer. This is a scale out alert which will be triggered when the number of hits will be more than the set threshold. In this case, the workflow will add the machines behind the load balancer. Now let me show you the current values of the HTTP request rate and the current session and the number of machines which are being placed behind the load balancer. As you can see, the current session is 0 and the HTTP request rate is also 0. As you can see, there are only two names which are separated by comma. So the number of members behind the load balancers are currently 2. Now let's take a pretty session of the Linux machine on which we will be running a utility which will increase the number of sessions and number of hits on the load balancer. So this is a scaleout.jmx utility which will be responsible for increasing the number of sessions and the HTTP request rate on the load balancer. The utility is being running and now it will take 2 to 3 minutes to reflect the new values in vROPs as the polling cycle for this machine is 5 minutes. Now as you can see that the number of hits on the load balancer has been increased to nearly 4,000 and the current sessions have been increased to 638. Now let's see whether the alert has been triggered in vROPs or not. The alert has been triggered in vRO Operations Manager. Now let's see whether this alert has triggered the workflow or not. This is a vRO orchestrator and this is the workflow for the scale out operation. As you can see that the workflow has been triggered. This workflow will take around 10 to 15 minutes to add a virtual machine behind the load balancer. As you can see that the workflow has been executed successfully. Now let's see the number of members in vRO Operations Manager. Earlier, the number of members behind the load balancer were 2. But now, after the execution of the workflow, the number has been increased to 3. So, this is how the scale-out operation works. As the number of hits will increase, the alert will be triggered in vROPs, which will ultimately trigger the workflow, which will in turn increase the number of virtual machines behind the load balancer one by one. Similarly, the scale-in operations work. If the number of hits on the load balancer decreases, the alert will be triggered for the scaling process and the number of machines which are behind the load balancer will be decreased by 1.